Let's move on. This is example. We want to create one entity class called book, another entity class called author, and we want to apply what type of relation here? Many to many. Okay. We want many to many association. Let's understand about how to define a many to many, and that too we want to make it as a bidirectional. Sure. We will do that. So requirement is I want to create an entity class called book, and I want another entity class called author. I told yesterday, many to many association, if you want to apply, it is a one to many plus inverse one to many. One to many with inverse one to many, and basically it is commonly called as many to many. That's what our requirement. We want to apply many to many, right? So what are the requirements? If I want to apply many to many, I need to create a collection variable. I need to create a collection variable. Okay, a collection variable in both the entity classes, because one book has list of authors. Similarly, what one author has list of books. One to many from book to authors. Again, one to many from author to books. One to many from book to authors. Again, one to many from author to books. And this is commonly called as many to many. This is called many to many. Okay, let's have a discussion on how we can do that. But one just point before I start example, I want to repeat that. If you want to apply many to many relationship between the two tables, it is not possible in database. Many to many relationship between two tables is not possible in database. In database, only one to many relationship is possible. Only what is possible in database? One to many only. Many to many is not possible in database tables. So in order to make it as many to many, you have to create one join table. Now the relationship is what? One to many from table 1 to join table. Again, one to many, inverse one to many from table 2 to join table. Now, how you are getting many to many in database tables? In a database tables, if you want to get many to many, then what? One to many from table 1 to join table plus one to many from table 2 to join table. Then the relationship becomes many to many between table 1 and table 2. Once again, I repeat how to provide many to many between table 1 and table 2. We need to create one more table in the middle. Who is the table? Join table. We need a join table. Then what I can say now, from table 1 to join table, there is a one to many relation. Again, from table 2 to join table, there is a one to many relation. Then you are getting many to many relation between table 1 and table 2. So basically what you understand, if you want to create any many to many relation between two tables, what is required in the middle? Join table is mandatory. Without a join table, you cannot apply or you cannot provide what kind of relation? Many to many. What is the purpose of the join table? To store the foreign keys of the two tables. Okay, let's see by writing the JP application. Okay. Let's create a Maven project. I can create a simple project also by skipping the archetype selection, but I don't want to do that. I just want to use the default workspace location. Next, I will wait for 10 seconds. Okay, these are all called archetypes. Maven archetypes. But which archetype? I need to choose Maven archetype pick start. Maven archetype pick start. So there are 3 archetypes with the name Maven archetype Kickstart from different vendors. I want to choose from Apache. Then click on next. Enter the artifact ID, means project name. JPA many to many is a project name. JPA many to many. I want to use package name com.aat.mtm. Many to many mtm. Finish. This is the group ID configuration. Confirm the properties configuration. Group ID com.aat. Artifact ID JPA many to many. Version 001-snapshot. Package com.aat.mtm. Is it yes or no? Yes. Build success. Build success. I got my project called JPA many to many. Let us first open pom.xml. In pom.xml, first I need to change the source and target versions. I want to use Java 11. 11 is the highest version we use in the applications in real time. Java 11 is highest version. Okay, many projects use Java 8 only. Java 8. Okay, some applications are started using Java 11. Java 17, 19, 20, 21 is not required. Java 11, if you know, that is more than enough. Unnecessarily, don't keep more weight on your head by learning Java 14 features, Java 17 features. Nobody will ask. If you know Java 8 features properly, 99% that is enough. You can tell, I know Java 8. I worked on Java 8. My project is on Java 8 only. That's all. If you know Java 8, that interviewer cannot ask you Java 15 features. Even I also don't know about Java 15 features. To be frank, I'm telling you. I know only Java 11 features. I never touched about 12, 13, 14, 15, 17, 19, 20. It's not required for me. Unnecessarily, don't put unnecessary subject into your mind, so that what is happening, necessary subject you are not putting in your mind. What is required to crack? First step is cracking an interview. Second step is surviving in the company. If you survive for first 3 months, you will survive further. Surviving first 3 months is very important. Okay. In first 3 months, every 15 days or every 1 week once, you need to cry. That's very common in IT. Because you have a pressure like that. Right, okay? Go to washroom. Right? Cry there. Wash the face. Come out. That's all. Initial days of the career, it will be like that only. A lot of pressure will be there. Right? First 2-3 months only. First 2-3 months, you will cry. After 3 months, you will make others to cry. Right. Okay. Let's move on. Okay. First, let us copy paste all the dependencies. Okay. It will take 2-3 months time to understand your project by you, to get an idea about your project, what is happening and all. After that, nothing is there. Same project will continue for years and years. Okay, right? So after copy pasting all the dependencies, next step, let us refresh once, update the project. So project is updated. We know under SRC main, we also need another folder called resources, but it is not created by default. We have to create it manually. So how do I create it manually? By using right click on main folder, create a new folder. Folder name is what? Resources. Resources. After creating resources folder, let us update the project for one more time. We can update any number of times we want. But inside these resources, we need meta in a folder because we need JPA persistence.xml file. Let us copy from previous example. We have to copy this meta in a folder into this resources. Paste it simply. Done. Now this is the persistent.xml. In persistence.xml, what I need to change is only entity classes because I want same database, same driver, same properties. For first example, whatever I've explained, it will be continued further in all examples. This XML, only what we need to change in XML, entity classes I need to change. Okay. What are the two entity classes I'm going to create is book, and other entity class name I'm creating is what? Author. That's all. One entity class name is book, another entity class name is author. We are done. We can close this now. We don't want this file again. Let us update it for one more time. Okay, right? We can update for many times. Right, okay. When you opened your ID, you don't have any work on ID also, you can simply for time pass also right click Maven update project. You can do it for time pass also. For time pass, what you are doing, simply right click refresh on the desktop now. When you are sitting in front of the system, okay, you opened actually with a lot of zeal, enthusiasm we call, na? You opened, you switched on the laptop. Once laptop is opened, once the screen is ready, charging is down. Now I need to write the program. Huh? Let's see, later we'll write. I know this logic, okay, no problem. Okay, then what we'll do, first we'll think for 2-3 minutes whether to open the ID or not. So meanwhile, what we do, right click refresh. Right click refresh means what happens, we don't know. We do many times right click refresh, right click, but really what happens when you right click refresh? Do you know really what happens when you know right click refresh? I don't know. I don't know really what happens when you say right click refresh 3-4 times. Right? It will clear the cache. System cache will be cleared. Generally, when your system is getting slow or something, what are you doing? Right click refresh, right click refresh. Why are you doing? Right? Hardware engineer also doing the same thing, na? Why he is doing like that? To clear the buffer. Okay. Don't worry about these errors. I want to create now one package called com.ait.mtm. One sub package I want to create. Entities I want. Actually, there is a file called app.java. We'll delete that file. Now com.ait.mtm.entities is the package. Let's start creating our classes. First, I want to create a class here. And first, I would like to name my class name as book. And I also want to create one more class, and I want to make my class name as author. Okay. Book is a class and author is a class, right? Book and author are the two classes. Let's start creating the properties. First, I want to make it as what? An entity class. @entity. @table. Table name equal to tbl_books. Okay. tbl_books is a table. Okay. Actually, to avoid writing constructors, setters, getters, toString, blah, 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 you have Lombok API. Okay. Lambda KP you can use if you know, otherwise you leave it. I am not using it. In spring, I will teach generally, not in Hibernate. So in spring already, Ashok will teach. Don't worry about that. Okay, you already know, then well and good. So at that time, you use that Lombok. If you are not writing setters, getters, something like that, use Lombok. At the rate data is sufficient. Okay. You use it, okay? At the rate ID. At the rate column. Column name equal to book underscore ID. Private integer book ID. So I have a class called book now. I have a class called book. Integer book ID. Book ID is ready. Next one is book name. Column. Book underscore name. I want to take only two properties now. But next one, this is where you need to understand. Book has a list of authors, right? That is called one to many. What book has? Book has a list of authors. What I'm taking here, private list of author. List of author. What I'm writing? Authors. You got it, right? Nice. Tell me what is the class name? Book. Book has what? Authors. Authors is a list. Means a book has a list of authors. This is called what field? Many to many field. It is not one to many field now, because we are applying what kind of relationship? Many to many. Suppose if I go to author, I'll come back and write the annotations here. I'll come back and write the annotations here. What the annotation I'm writing here? At the rate entity. At the rate table. Table name equal to what? TBL underscore authors. TBL underscore authors. Next what? At the rate ID. Column. What is a column name? I want to write column name equal to author underscore ID. Private integer author ID. That's all. What next after author ID we need? Author name. So how do you write now? Column. Column name equal to what I write? Author name. That's it. Author underscore name. I took my column name, author underscore name. Private string author name. Next, what I need to explain you next after this? I want to create a private list of books. So what you understood now? What you understood now? Book has a collection of authors, and also an author has a collection of books. This is called many to many, one to many, and inverse one to many. One to many with inverse one to many is called many to many. That is what we are doing here, nothing more. One to many with inverse one to many, basically called as many to many. Yes, we do that. Coming to annotations now. First of all, this is annotation at the rate many to many. What's annotation at the rate? Many to many. Cascade equal to what I say? Cascade type dot all. Cascade type dot all. Basically, correct. That's okay. What is a default fetch type? Lazy. Or the default fetch type? Lazy. Sometimes I'm telling eager, sometimes I'm telling lazy. You are finally confused when to type eager, when to type lazy. Here the default fetch type is lazy, not eager. In a many to one, what I told? Eager. In a one to one also, I'll tell eager only. Next. Means simply you remember the last word. What is the last word? 2 1. 2 1 means shortcut. 2 1 means If relationship ends with a 2-1, fetch type is eager. If relationship ends with a too many, lazy. That's all. One to many, what's the default fetch type? Lazy. Many to many, fetch type is lazy by default. Many to one, eager. One to one, tomorrow we are going to see. Eager. You're getting my point, right? Too many means fetch type lazy. Too one means fetch type eager. Too many applied on a collection variable. Too one applied on a reference variable. One to many. If you want to apply one to many, you need collection variable. Many to many, what is required? Collection variable only required. If it is many to one, you need reference variable of target entity class. One to one, reference variable of target entity class. For example, I want to apply a person has a passport. What kind of relation it is? One to one. One person cannot have two passports, right? We cannot apply one to many. We can only apply one to one. We can apply only one to one. Right? Are you getting my point? Right. One husband has one wife. What kind of relation? One to one. One to many also possible. Okay. One to many also possible, but actually it is one to one. Okay, right? Okay. Okay. For example, if you take like that, one person has one passport. So how can I apply one-to-one relationship between person and a passport? I need to create a reference variable. Person is a source entity class. Passport is the target entity class. What I do? I'll create reference variable. Means in person class, I will create a passport variable. But I cannot create a list of passports now. Why? Relationship is 1-to-1, that is. If relationship name ends with a 2-1, what is required? Reference variable of target class is required. If relationship is ends with too many, collection variable required. That's a very simple thing to add. When to create collection variable, when to create reference of target class. So these two you can identify based on the type of relationship. What's the type of relationship? Either too many or 2-1. Currently what we are discussing? Too many. Too many means definitely what is required? Collection variable. Next. Observe here. At the rate join table. We have a join table now. Join table has join columns. Tell me first of all, what is the name of the join table? TBL underscore books underscore authors. Yes. Understand here. What's the name of the join table? TBL books authors. Annotation is join table. Nice, good. Join table annotation has 3 attributes. You know, annotation has attributes. Annotation has attributes. Sometimes we call them as elements. Attributes are elements. We can say something. So what I'm saying now, join table name. What's the table name? TBL underscore books underscore authors. Name of the table. Next element. Next attribute. Join columns. I'll tell you. I'm not writing any value, just I'm telling you. What's the next element? Join columns, comma, inverse join columns. So what are the 3 elements or attributes of join table? Name of the join table, join columns in join table, inverse join columns in join table. Are you getting my point? Once again, I repeat, what are they? Name of the join table, join columns in the join table, inverse join columns in the join table. 3. Let's start about join columns. Again, I need to open the table to explain. Here, what is the foreign key in the join table that refers the primary key of the books table? Book underscore ID. This is foreign key column in what table? Join table. In join table as a foreign key. What's the join column name? Join column means foreign key column. What's the name? Book underscore ID. It refers primary key of the books table. That is called join columns. What is inverse join columns? In the join table, join column is there. Inverse join column is also there. Who is the inverse join column? Author ID. Inverse means this is another foreign key column, right? So this inverse join columns means foreign key in the join table, which refers primary key of the target entity. So tell me, who is the inverse join column in the join table? Author underscore ID. But who is join column? Book ID. Book ID. Book ID. So annotation, what I should write? @ join column. Okay. What's the annotation I should write? @ join column. Join column name. What is the name of the join column? Book underscore ID. Book underscore ID. Okay. This is the foreign key. This is a foreign key in which table? Join table. This is a join table. In the join table, this is the foreign key column. Foreign key column is represented with or specified with join column annotation. This annotation can be used to specify what key? Foreign key. What is the foreign key here? Book ID in the join table. Why I am not writing author ID? Book ID is the foreign key. Author ID also foreign key only. But why I am not writing author ID? Why I am writing only book ID here? Which foreign key column you should write here? The foreign key which refers primary key of the books table. This because this entity class is mapped with the books table. Huh? Tell me who is the foreign key in join table that is referring the primary key of this books table? Book ID. What is the primary key name in that books table? Book ID. Okay, both are having the same name. I can even write one more element. This is optional. Referenced column name. Name means primary key referred by foreign key. You know already foreign key refers primary key only, na? Foreign key of a table refers what? Primary key of the parent table. Referenced column name means what column name? Referenced column name means which column name? Primary key column name, foreign key column name? Primary key column name. Join column name means what? Foreign key column. Name means foreign key column. Referenced column name means primary key column. If you are confused with the same names, book ID, sir, I am getting some confusion. You can do one thing. Use foreign key as underscore FK. Do you have any rule like that? Foreign key column name must match with primary key column name. When I am creating a child table, we are creating a foreign key column. Do you have any rule like that? Name of the foreign key column in the child table should match with the foreign key column, primary key column name in the parent table? No. We can use our own name, whatever we want. Correct? We can use whatever the name we want. If you are confusing, you can use underscore FK, but I have explained very clearly. Here, second element is mandatory or optional? Optional. We can leave it optional. Optional, basically. Next, inverse join columns. What is the inverse join column? Join column annotation to specify the foreign key column. What is the name? Author underscore ID. Who is this? Primary key or foreign key? Foreign key. Or the next one? Referenced column name. Who is the referenced column name? Author underscore ID. This author underscore ID is a foreign key or a primary key? It's a primary key. We are done. Okay. We just want to create a setters, getters. Okay. I'm creating all the setters and getters. This is ready. Let's go back to author table. Author class, sorry. Author class. Here also I created one collection variable. Why I created this variable? Why I need this variable here? Because our relationship is what type of relation? Many to many, bidirectional. This is called what field again? Many to many field. Many to many field. But as I said already, how to tell Hibernate that it is a bidirectional relationship mapped by, what is it? Yesterday I told you one to many bidirectional. How to tell Hibernate that it is a bidirectional one to many? In a one to many, we are writing mapped by is equal to many to one field. In a one to many annotation, there is a mapped by element or attribute is equal to what we have written? Many to one field. One to many mapped by many to one. That is called bidirectional one to many. But what about many to many? Many to many mapped by many to many. So what is the element I should write? Mapped by. Mapped by is equal to, what is a many to many field? Authors. What is a many to many field? Authors. Mapped by authors. This is called, this is authors. This is the name of the field. It is a many to many field, right? It is a many to many field. So how to tell Hibernate that it is a bidirectional many to many? By using this element. What is the attribute? Mapped by. Mapped by what? Authors. Mapped by authors. That's all. If you write like this, it becomes what type of relationship? Many to many bidirectional. Bidirectional advantages, or what is the advantage of bidirectional? What is an advantage of bidirectional? Yeah. Application can do operation from either book entities or from author entities. Right? If, for example, application does operation book entity reflects on authors, and if application do an operation author reflects on books. Book operation reflects on authors. Author operation reflects on books. Now this is called what kind of relation? Bidirectional. If it is unidirectional, if operation is done on book, reflects on authors. But if operation done on author does not reflect on books, it is called uni, bi and uni, two ways. Unidirectional, bidirectional. Currently, I want to make it as what? Bidirectional. So which element I have to use to make it as bidirectional? Mapped by. Mapped by. Again, don't write join table annotation, because this many to many will get all the join table information from this field. What's the field name? Authors. This authors field also contains join table information, right? So this many to many will get all the join table data from authors. So don't write again @ join table. This is not required. This is not required. Done. Setters and getters required, so we'll create them. Let's create them. What is done now? All the setters and getters are created. This is the book entity class. This is an author entity class. And finally, we got book and author. We are ready. Entity classes ready. Entity classes ready. Let's start doing the operations now. Means what I want to create first one? DAO interface. DAO interface first we create now. Okay, let me create a DAO interface. New package first I want to create. Package name is com.ait.mtm.dao. What I'm creating here, one interface I'm creating. What's the name? New interface. That interface name is book DAO. What's my interface now? Book DAO. I want to create an interface called book DAO. Inside this book DAO, first I want to save a book. I use return type void. I want to save a book. Pass the book object. Argument is book. Again, book means one user defined class is there called book. There is one predefined class is there called book. We have to import our class. This book is what second one? It is from AWT package. Abstract Windowing Toolkit. AWT, java.awt. AWT applets, they are gone long back years only. Okay, right? So we don't have applets AWT concept today in Java, core Java. Okay, we leave it. Okay, this is our class. Book we are importing. This is to save a book. Next one is find book. Find book with book ID. What is that? Find book with book ID. That is to find. Next one is to remove a book. Based on ID. Means what are all the operations I want to implement in my DAO first? Save means inserting, selecting, deleting, updating you do. Okay. I want to implement three operations: save book, find book, remove book. This is my DAO. I should start writing implementation class, right? I want to create a new package. What's the package I'm creating? DAO.impl. I'm creating one new package. In my DAO.impl, what I'm creating? New class. And my class name is book DAO impl. And it implements an interface called book DAO. Finish. And here, first we need entity manager factory. Private. Entity manager factory. Factory equals to persistence dot create entity manager factory of test. That is my persistence unit name. In the XML, I gave test as a unit name. Now, let us talk about the save book. Sure. I want to save a book now. But if I want to perform any operations, first what we need? Entity manager reference required. Create entity manager. Entity transaction also required. Correct? Because it is an insert operation, right? Transaction required. T is equal to em.get transaction. T.begin. Correct? Try block. Try block. Once you begin the transaction, what next you have to do? em.persist. What you want to persist? Book. If it is persisted successfully, then commit. If it is committed, just write a message that book is inserted. Book is inserted. Blah, blah, blah. Define a catch block. Exception EX. Roll back if there is an exception. Print that stack trace also. right? Print that stack trace also. Finally, close the entity manager. Common code. This is to perform what operation? Save. Similarly, what's the next operation? Find. But to find a book, we don't require transaction. Find means selection. Na? We don't require. What we need? Entity manager required. So entity manager is created. What next after doing this? Find. Reference variable name book equal to em dot find of book dot class, then book ID. Okay, right? em dot close. Return that book. Return that book. You got it, huh? Okay, this is for what operation? Find operation. What's the next one? Remove. But to remove, transaction required. Remove means what? Delete. To perform insert, update and delete, what is mandatory? Transaction. For select operation, optional. Optional. Transaction is optional. Yes. Done. Okay. Right. What should I do now? T dot begin. Try. First find. Find means you want to get it now. You want to get it here, right? Find. After getting the book with a given book ID, then delete it. How can I delete? Remove. Remove a book. If it is removed successfully, then commit. If it is committed, you can write a message saying that book is deleted. Correct? If there is an exception occurred, then T dot rollback. Print that stack trace. Finally, em dot close. Close the entity manager. Got it, right? Now, almost in all our DAO, code is looking same, right? In one-to-many or even in many-to-one or many-to-many now today. But in the main class, code is different. You are going to see that. Currently, DAO is completed. What's the next step? I should write one main class. How can I test all these methods? Whether these methods are working or not working, how can I do the testing? I can write a, yes, main class. Let's create main class. I'm writing new package I'm creating. com.ait.mtm.test. Okay. One new class with main method we are writing with the name tester. First, let's create an object of DAO class. How can I create an object of DAO class here? Book DAO. Reference variable name DAO. Book DAO IMPL. Got my point? Book DAO is equal to new book DAO IMPL. DAO is a reference variable, na? Yes. What's the next step to do? I have to call the methods now. Which method first I want to call? Save book. But if I want to call save book, suppose I want to call the method save book. I need object now. Book I need, right? To that book I need to set authors. Means I need book and authors now. So first what I am creating? Book objects and author objects. I am creating. Create book instances. I'll create two book instances now. B1 equal to new book. B1 dot set book ID na. Book ID 10101. B1 dot set book name learn Java. One book is ready. Let's create a second book object also, B2 equal to what I'm writing, new book, B2 dot set book ID 10102. B2 dot set book name, right? Boot essentials book name. Okay, I'll change it. I'm done. B1, B2. Two books are enough to easily understand. Let's create what next? Author instances. See, author instances. Author A1 equal to new author. First, let us create the objects to test. If I want to test the operation, first I need objects. I have to create all objects here. Okay, we need patience here. A1 dot author ID. Author ID 90101. That's author ID. Author name is Garden. Next one. A2. Right? A2. Second author 90102 is author ID. Okay, right? Author ID. Name is Blake. Let us set with A2. Correct. Next one. Let us find for A3. Right? A3. A2, A3 now. A3 dot set author ID 90103. A3 dot set author name. Okay, John. Okay, let's see now. So what are A1, A2, A3? Authors. Now observe here. I'm creating list of author. List of author. Authors of book 1. All right. List of authors of book 1 is equal to, I want to take big variable name. List of authors of book 1 is my variable name. Okay. Meaningful names required. List of authors of book 1 equal to arrays dot as a list A1 comma A3. So who are the authors of the first book? A1 and A3, two authors. A1 and A3. Right? Means Garden and John. Garden and John. B1 dot set authors of list of authors of book 1. What is B1? Book 1. What I am setting? Authors I am setting. How many authors I am setting? 2 authors as a list. Next I am creating another list. Or the next list of author. List of authors of book 2 is equal to arrays dot as list A1 comma A2 comma A3. Okay. Then what I set next? B2 dot set authors. Tell me who are the authors of the first book? A1 and A3 and B2, all the three, A1, A2 and A3, which you can understand what A1 is an author for. A1 is an author for 2 books. A1 is an author for 2 books, B1 and B2. Even A3 is also an author for 2 books. Means what you understood here? One book has multiple authors. One author has written multiple books. It is called what kind of relation? Where can I able to find the many-to-many relationship? Join table. Where can I find it now? Join table. In join table we can find, because where is foreign keys? Join table. Without foreign key you cannot identify the relationship, right? If there is no foreign key column, table 1 is there, table 2 is there. Can you find any relation between them? To make a relationship, to find relationship, what key is required? Foreign key is required. Without foreign key, you cannot find relationship. But where is my foreign keys now? Join table. Where can I find the relationship? In join table. Means after execution, which table I need to open to see whether there is a many-to-many relationship between the book and author or not? Join table I have to open. I'll open the join table. Sure. But first let us call save operation. DAO dot save book. B1. DAO dot save book. B2. Let's open workbench. Okay. If I want to check whether do I have any table called TBL underscore books or not? I don't have. I want to check whether do I have any table called TBL underscore authors or not? I don't have. Even I also want to check whether do we have any table called books underscore authors or not? I don't have all the tables, right? That's good. Automatically tables are generated by Hibernate only. I have to run this code now. Integrity constraint violation exception. Very good. I will tell you. Rollback exception. Constraint violation could not execute statement. Which statement? Identify. Duplicate entry 90101 for key tbl underscore authors dot primary key. Like this, even earlier also we got this kind of exception. Earlier, right? We got this kind of exception earlier also, right? Why? Because when it is inserting, what is happening while inserting? It is going to check whether this particular 90101 exists or not. If exists, it should continue. Otherwise, it should insert. But what is happening here? If exists, it is throwing exception. Exception saying that what? Constraint violated. Constraint is violated. That's what exception we are getting, right? Constraint violated. We are getting an exception. What we want to do now, we want to find a solution for this. When we are discussing about many to one also, okay, when we are discussing about many to one also, we got the same kind of exception, right? The solution to get out of this problem is change the cascade type. Change the cascade type as merge. For the cascade type, I need to change, merge. Merge represents 2 operations, inserting or updating. Merge meaning either inserting, persist means only inserting, does not mean update. Doesn't mean update. So what I'm writing here, cascade type dot merge. Let us run. Before I run, I want to go to my workbench. If any tables are created, I want to drop them so that new tables are created for me. Drop it. Even drop it. Okay, then I can drop it. Yes. I can run this application now and we'll get the output. Author underscore ID. Cannot add or update child row. No problem. We don't worry. Because I think I forgot to write cascade in author. Only mapped by a written. What should I write here also? Cascade. It's a two-way relation. Cascade type dot merge. Cascade type dot merge. Then what's the next element? Mapped by. Mapped by is equal to authors. What is missing here? Cascade attribute is missing. I think I've written only mapped by, but I have not written cascade. That's the reason why I got this kind of exception. No issue. Then we'll get the result. Okay, I'll show you. We should cascade for other side also. Because relationship, we are making it as bidirectional. Na? So cascade must be applied on both sides. That's what I forgot. Okay. Cannot add or update or a child row, so and so. Why? I'll update my project once. Just a minute. We can able to find the result. We can able to find the result. Let us update the project once. We are done. Okay. Then we'll run. We'll see. Inserting into books, inserting into authors. Inserting into books, inserting into authors. But not inserted into TBL underscore author. Okay. I'll rectify. TBL authors of author ID, but it is not inserting into that particular authors table. Okay. I have nothing to worry. I'll do that. Okay. It's two-way. Here cascade equal to merge and here cascade equal to merge are written. Cascade type dot merge. Merge means updating. We'll do one thing. Inserting there. Okay. We are done. I'm going to execute it now. Persist method, merge method we called. We'll check. If not, then we'll do in that way. In place of persist method, we called merge method last time. Okay. Here I'm using persist merge. Otherwise, cascade type all I'll apply. Okay. Done. Right. Two books inserted. One book and the other book. Okay. Right. Let's see. First of all, let's see the tables now. Tables. Select a star from book. Sorry, TBL underscore books. So two books are inserted here. One is Learn Java. Next one is Boot Essentials. Next one, select a star from TBL underscore authors. Three authors inserted, Garden, Blake, and John. But you cannot find the relation. This is books. This is authors. Can you tell me, by using these tables data, can you find any relationship between them? No. No. But where can I find relation between the book and author? Join table. Select a star from TBL underscore books underscore authors. And now this is the join table. Let's see the join table. Now, if you look at the join table, this join table contains how many foreign key columns? 2. What are the foreign keys? Book ID, author ID. Now, if you observe these two records, what is 10101? Book ID. But what are the author IDs? 90101 and 90103. Means what you understood by this box? One book has two authors, means one to many. Okay. Let us identify the next one. The next one is, we have 90101 here and 90101 here also. Now I have selected two boxes now. What you understood with this? 90101 is the author ID, but what are the book IDs? 1010101 and 10102. Means what you understood? This author, same author, has written two books. Means what? You have one too many and inverse one too many. Where can you find that? Where can you find the relationship as many to many? In this table. This table is called what table? Join table. This is what our output for today. So what's a small change I did is I called merge method in place of persist method. In my DAO, instead of calling the persist method, which method I called to get a solution for this problem? Merge method I called in place of persist method. Okay. Currently, one operation we have tested. What operation? Save book. What are the other operations in DAO? Find book is there. Next one is remove book is also there. Okay. This is what we will see on tomorrow. Okay. That's it for today. I will continue this example tomorrow also. After that, we'll see one-to-one relationship. Okay. Thank you. Guys, that's the session for today. We will continue on tomorrow. Okay. We'll continue on tomorrow. We'll continue this example on tomorrow.